Following on from the previous two videos, our aim here is to show that this is exactly the same as this. And the way we do that is to rewrite this number a here as the number a as something to the power of another thing. And don't forget, we can always rewrite this as let's say 2 to the power of something. So remember from the previous video, when you have this graph here, let's say 2 to the power of whatever here. If you give any number a here, you can always rewrite it as something to the power of another thing, even if you have y equals 10 to the power of x. You can always rewrite. So 10 y equals 10 to the power of x. It's going to look something like this. You can always rewrite the number a as 10 to the power of whatever. My point is, it doesn't matter what this number is. It doesn't matter what the base is. You can always rewrite whatever number this is to the power of another number. Okay, so the trick is to show that this is exactly the same as this here. You rewrite this number here as one thing to the power of another thing, and then later on you can put it into here. Okay, and then for some reason it will cancel itself out. So here, so the trick is to rewrite a as a to the power of another thing here. So whenever you get this statement here, you can always jump to this. You will automatically get this statement here. So whenever you get this statement, you will automatically get this statement here. So, and remember, if you have this statement, you can always automatically jump back to this statement. Okay, so when you have this, you will automatically get this. Okay, so remember this block here. Later on, we're going to come back to this block. So start out with start out by having a equals this thing here. So look at this, a to the power of x. So let's power it to power it to the x to both sides. So here at the moment we are here, power by x to both sides. So this will then give us this, and then this side here, power it by x. That will then give you this. Okay, yeah, and then this here. Remember, whenever you have x to the power of a and then to the power of b, which is in this case here, you've got power and then to another power. That equals, from our indices, it equals from our section on indices, it equals x to the power of ab. So this thing here is the same as this thing here. Okay, so now here's a trick. Log base z to both sides. So log base z to both sides. That will then give you, the left hand side will give you this, the right hand side will give you this. And remember this, in a way it becomes this. Okay, because if you translate this, your eyes zoom into the z here. Z to the power of what will give us this thing here, will give us this thing here. And you see, the only thing that can exist in this bubble is nx, which is this bit here. So when you're here, take the log base z to both sides. So that will then give you this, and then these two will cancel each other out, giving you this. Okay, so this side equals this side here, and then if you look right from the start, remember this n here. So at the moment you've got n times this thing here. Remember the n here. Right from the start here, hang on, remember, whenever you have this statement here, you'll automatically get this statement here. So this n here equals this thing here. So let's put this thing here back into the n down here. Hang on, back into the n down here, back into the n down here, back into the n down here. Okay, so put that thing. Put this thing here, because this thing here equals n. So put this thing here, because whenever you have this statement, you will automatically get this statement. So let's put this into the n down here. Okay, so that will then give you this. So this here, this is your n here, and then this here is your x here. So let's just switch these two around. Switch the x, switch this around. So this goes over here, and then this goes over here. So it becomes this. You see, now you can see that whenever you have this statement here, that's the same as this. That's the same as this thing going down here. You see, now these two are the same. The important thing that you should note the important thing to remember is that here we've got log to the power of z here. So, but z could be anything. You could take the log of anything and it will still work. Because if you look up here, you've got a. We're rewriting a as z to the power of n here. But we could write a to the power of anything. So here we could write to the power of, let's say here you've got y equals 7 to the power of x here. So we could rewrite a equals 7 to the power of something. But the thing is, the base could be anything. It does. You see here you see this z here could be anything and it will still work. Your calculator defaulted it to the base 10, but this rule here still works even if you have, say, to the log of 3 or to log of base 3 or log base 4, or it could be anything. It's z could be anything. So this here is true. So whenever you take the log of this here, it becomes this. But then don't forget, you could say 10 and then this here will still be true. Log base 7, this here will still be true. So it doesn't matter what the base is, it will always be true. Okay, bear that in mind. That's quite important. Okay.